uh, to interface electrical and electronic circuits using Tinkercad and to design a LED flasher. Okay, so we have to design the LED flasher program with the help of a Tinkercad software. Okay, so what we need for this particular experiment, we need a Arduino board, LED, resistance of 220 ohm. Okay, what is the theory behind this? In our phones, in our cars, or in our homes, anytime something electronic lights up, there is a good chance that an LED is behind it. They come in a huge variety of size, shape, and color, but no matter what they look like, they have one thing in common. They are the beacon of electronics. They are widely purported to make any project better, and they are often added to unlikely thing to everyone delight. Okay, so LED are a particular type of a diode that convert electrical energy into light. In fact, LED stand for light emitting diode. It does what it says, the tin, and this is reflected in the similarity between the diode and LED schematic symbols. Okay, so here you can see the symbol of a diode having two terminal. First terminal is anode and second terminal is cathode. So you remember this thing, that anode will flow the current, or anode will pass the current from this particular LED, whereas cathode will block the current. Why it is so? Because the current is flowing only in one direction in diode. So anode is positive, cathode is negative. So current will flow from anode to cathode, means from positive terminal to the negative terminal. Okay, so inside this diode we have a PN junction. Okay, so generally this LED, light emitting diode, will emit the light. Okay, so that's why you can see some LED are flashing. In Diwali you will see most of these LED flashers, they are designed with this Arduino software or Arduino hardware. Okay, so here we can see in LED where we can use this. There are so many applications in your computers, in your torch systems. Okay, so these LEDs are used. So how we can perform this particular experiment? You can see the circuit diagram right here. We have a breadboard. On that particular breadboard you have to place the anode. So anode should be connected to the positive supply, and cathode, you have to connect that cathode to the ground. Okay, so this is the circuit which you have to create in Arduino UNO board, and we are using a software which is called as a Tinkercad. In that Tinkercad software, this particular this Arduino UNO board is also available, LED is also available, and resistance is also available, and the breadboard is also available. So we will use the Tinkercad software to perform this particular experiment. Okay, so let's understand the program behind this particular uh, experiment. Okay, so here you can see in this program, what we are doing right here, we are using the void setup function. We are using the void setup function. Generally this setup function is used for hardware setup. Hardware setup. So which hardware we are using right here? We are using Arduino UNO digital pin. Okay, so you have seen the circuit board right over there in a Arduino UNO. Let's suppose that this is a pin number 13 that should be connected to the anode of the LED. Okay, this is your LED. Let's suppose that it has anode and cathode. Two legs are there. Okay, it has two legs, anode and cathode, and cathode should be connected to the ground number pin. Okay, and you have to connect some resistance over there. Okay, so this particular circuit we have to initialize in the programming. Okay, we have to set up the hardware function of the pin. Okay, so initially what we are using the function pin mod. So what is the use of this function pin mod? Its use is to define define the pin function. Either that pin can be used for the input or that pin can be used for the output. So we will define the function of that particular pin. Okay, so this setup is closed right here. Only one pin we are using, that's why we are using the pin mod 13 as an output. After that, what we need to glow this particular LED, our task is to on and off this LED. Okay, and continuously this operation should be performed. Okay, so that we can see the blinking of this LED continuously. Okay, for that we have to create a loop. Initially we will set this LED to on, and then we are going to place some delay. Okay, so what is delay? Delay is nothing but a waste of time. So why we are wasting a time right here? Because in this Arduino UNO, okay, the microcontroller is very fast. Microcontroller is very fast, and you will not segregate between the on and off position of this LED. Okay, so that's why we are using some delay to segregate between on and off position. Okay, so initially we will set the LED to a on position, then we will use some delay, then again we set that LED to the off position, then again we use some delay. Okay, again we use some delay, and again we will switch on that LED. So this process continuously work until we switch off the board. Okay, clear everyone? So how we are performing right here? We are using the void loop function right here. Inside this function, what we are writing, as the name suggests, loop. Loop means continuously it will work. It will work in a loop. Okay, so initially we are using this digital write. So what do you mean by digital write? We are writing on pin number 13 as a high. So what do you mean by high? High means you have to set the voltage to 5 volt. Okay, so on this 13 number pin, digital write will set the voltage to plus 5 volt. Okay, then we are using a delay. So what is delay? Delay is waste of time. So this 100 is a millisecond. Okay, so this is a millisecond time which is used for wasting the time. Okay, again we are using the digital write function, and we are setting this pin number 13 to the low position. That means we will set the voltage level to 0 volt. Okay, then again we are providing a delay of 100 millisecond, and we will close this program. So this loop continuously work. Okay, this loop continuously work, and it will stop when you switch off the circuit. So click on the login page, okay, and log in with your Gmail account. Here you will find a create new circuit, okay. So click on this create new circuits. The breadboard. So firstly, we drag the LED. We drag the LED. You can see right here. We place that LED right here. When you scroll your mouse over the LED, you find the diodes terminal. Okay, so this terminal is cathode and this terminal is anode. That is Arduino UNO. Arduino UNO. You can scroll this. Here you will find Arduino UNO R3. Drag that component and drop below the breadboard. LED has two terminals, anode and cathode. So anode should be connected to the positive and cathode should be connected to the negative. So connect this anode to which position? To distal pin. Okay, positive. This is the positive. So this distal pin 13 is a positive supply. Plus 5 volt it will provide you. Right. So here is the ground pin. Here is the ground pin. So you have to connect this negative to the ground pin. This is the ground pin. So you can change the wire color. So negative stand for black, okay, black color. So you have to place this color as black, and here you have to place red color for the positive. Now what you will do, you will click on the code, and there are three different options right here. You will find the block also, you will find the text also, okay. You will find the block plus text also. So first we will start with the block, okay. So in the block, how we can construct a programming task, you have to click on the code, and right here we have set built-in LED to the high position, and then we have placed the delay of 1 second. So it is very high delay. We are using 1000 millisecond delay, okay. So 1000 millisecond delay. And then what we are doing right here, we will use the set pin. What is the next pin? Pin number 12. Okay. What is pin number 12? Initially, we will set that pin number 12 to high. Then we will use the control option and we will use this delay block from here. And we change the delay to 1000 millisecond. Okay, 1000 millisecond. Again we will click on the output, and here we will use the set pin. Which pin we want to set? We will set the pin number 12, and we will set that pin to the low position, and again we will use the control option and we select that delay block, and we place that delay value to 1000 millisecond. Okay, that's all. Our program is completed. Now we have to execute this program. So here you will see the start simulation. Okay, so now what you have to do, if you want to change the LED to the green, you can change its color. Now I am starting the simulation, and you will see this LED is glowing. Okay, so first red LED is glowing, then green LED is glowing. So what we need for this particular experiment, we need breadboard. Okay, drag the breadboard. Then we need one resistance, okay, one LED, and one Arduino. So you have to select the Arduino, grab that Arduino from the component list and drop inside the working environment. Then you have to select the LED. Okay, so we are using right here LED flasher program. So you can use multiple LED also, or you can use the single LED also. Okay, so let's suppose that I'm using 4 LEDs right here. So you remember that anode should be connected to the positive and cathode should be connected to the negative. So across the anode, you have to connect the resistor. You will click on the output. You will click on the output, and here you will find set pin. So select this block, set pin. So which pin you want to select first? You can say first pin is 13 number pin. So select that 13 number pin, initially set that to high, then go to the control statement, and here you have to use the delay. So select that block and place that block and put the delay timing. It's up to you which delay you want to set. I am setting 100 millisecond. It is enough. Okay. So I will delete, I will add two more blocks right here. Okay, so what I will do, I will select this and duplicate this block, and I will place this block right here. Okay, so changing the high position to the low, and this wait uh, or delay will be set as 100 millisecond. So I am not changing it. So again I will select this block and I will duplicate this block, whole block. Okay, so now I am just changing the pin number. So what is the next pin number? Next pin number is 12. Okay, so initially 12 number pin is set to be high, then I am using the 12 number pin to the low. Again, I will select the whole block and I will duplicate it, and I will place this block below this block. Okay. So select that 11 number pin. Initially that 11 number pin is set to be high. Okay. And then you will put that 11 number pin to the low. Then delay. Then 11 number pin is to be set as low, and again a delay. Then we are going to set the pin number 10 as high, and again we are going to set uh, these two blocks. We have to put two more blocks right here. So what I am doing, I am setting this pin number 10 to the low position, and again I will click on the control and select this delay block and put delay right here 100 millisecond. Okay, 100 millisecond. So our programming task is completed. Okay, you can check the code right here in the form of text. Okay, here what we have set, we have used the setup log, we have set the pin mod 13 as a output, 12 as a output. Okay, and 11 as a output. You can see this code right here. This code is auto generated with the help of these blocks. Okay, then we are using the loop function. Here initially we set pin number 13 to the high, then we will use a delay of 100 millisecond, then we will set a pin number 13 to the low, again we will set the delay of 100 millisecond. So this process is used for the one pin. So we are repeating the whole process for other pins also, and you can watch right here, same 4 line of code is repeated multiple times. Okay, so same code is used for other lines, other pins also, or other LED also. Okay, if you want to change the timing of this, you can change the timing of this. Okay, this is the red LED. If you want to change it to the green, you can change it. If you want to change this red LED to yellow, you can change it. If you want to change it to the orange, you can also change it. It's up to you. Okay, so start simulation. Here you will see all LEDs are blinking right now. Okay,